So what have we got? A summary of 30 values of x gave the following information. So what have we got here? We have sum of x minus c is equal to 234, and sum of x minus c all squared, it's a minus there, is equal to, is it 1957.5, is that right? And we have 30 values of information, and c is a constant. And our first step is to find the standard deviation. So that's sigma, isn't it? Right? Okay. Now, what do we know about standard deviation when we code data? The standard deviation, so we've taken x and we've subtracted this constant off each time. So the standard deviation, or the measure of spread, is not actually going to change at all, right? The measure of spread will be the same. We've just shifted our data by the constant c. So standard deviation will be the same in both cases. And we know that standard deviation, we know that variance is equal to, so this is equal to this. So this is one of the formulas we learned earlier on, over the number of items of data, frequency, subtract the mean, which we wrote like this, squared. Okay, now the mean squared in this case how do we find a mean? We know that n is 30, just going back to that because we've got 30 values. The mean is the sum of the data, which is this, divided by the number of values. That's how we get a mean, isn't it? Add all the data together and divide it by frequency, and we're going to square that. If we want to get this, though, the standard deviation, we are going to square root all of this. Does that make sense? Last step is just to put in what we do know. We actually do know what this is, don't we? Because it's been given to us in the question. So my next step will be to chuck in what I do know. So it's 1957.5 divided by 30, subtract 234 over 30 all squared. And chuck that into our calculators and see what we get. I'm just going to grab mine. And we're getting 2.1. 2.1? 21 over 10. So that's the first step. The second step is, given the mean of these values is 86, find the value of c. The mean of the values of x is c. That means that, so this is part 2, if the mean of the values of x is c, that means sum of all of the x values divided by 30, is 86. So the second part of the question says, given the mean of these values is 86. So I've said sum of x divided by 30 is 86. And therefore, the sum of x, all of my x values, must be 2,580. I've just multiplied both sides by 30 to find the sum of x. Now, what you want to do now is find the mean of the coded data, and we compare, because what happens to the mean of the coded data is it shifts by this constant, right? Because we're moving all of our values by c, and therefore, if we find the value of the mean of the coded data and compare it to this mean here, we should be able to actually find how far it's shifted. Okay? Alright, so my next step, I'm going to go this over 30 will give me the mean of the coded data. Two, three, four over 30. What does that give us? 7.8? 7.8, yep. So compare how these have shifted. This is the original values, and I've shifted them like this. What must C be? 78.2 is correct.
So you don't need to do anything with the sum of?
Oh, well, I did here. I used the sum of x minus c to find the mean of the coded data, and then I just compared it to the mean of the non-coded data, and because it's just a simple shift, we can compare those and find out how much it's shifted by. Okay, Swati measured the lengths x centimetres of 18 stick insects, so 18, so n is 18, right? Well, are you just trying to work out how he did this, or why he did it?
Why?
Because it's maths, right? And we know that the sum of x squared is 967, and we know that the mean is 58 ninths, and we are asked what is this of the coded data, so we've got to find out that, and we also need to find out this again, coded data. Okay. Now is not the time to panic. What we need to do is, let's think about our mean. This is our mean. So we could find the total mass, couldn't we? What is it, lengths or? It's lengths, okay, so we can find total length. Therefore, total length, which is going to equal this, times 18. Yeah? And that is basically this, isn't it? Sum of x. So what do we end up with? 116, I think. That's the total, grams. Centimetres, we're doing lengths. Okay, now let's think about this. That's the sum of x. But if we're doing the sum of x minus 5 for each of the 18 stick insects, we're taking off 5 centimetres. So it's going to be this. Subtract 18 lots of 5 centimetres. Because for each of those 18 stick insects, we took off 5 centimetres. Are you following the logic there, Hassan? That's making sense to you? Yeah? Rebecca, are you happy? Nice. And this gives us, well, we can double in half here, can't we? So 10, 9 is 90, so it's just 26.
Could you have done it by adding 5 to the mean and then multiplying by 18?
Yep, yep.
Okay.
Yep. So try that.
Dividing.
So what's our original mean? So we've got to subtract, we're subtracting 5, don't we? Okay, and then multiply by 10. Yeah, perfect. Yeah, Very good, you're getting the way it works, that's fantastic. Okay, what's our next task? Oh, so we've got to get this. Okay, yeah, how could we do this? Well, we could just think about variance, because variance remains the same between the coded and the uncoded when we're just doing a shift like this. So why don't we work out the variance of the uncoded data? So variance equals this divided by n, subtract the mean squared. And we can work this out. Well, we know sum of x squared, 967, all over 18, minus 58 over 9 squared. What are you getting there, Rebecca?
12.2.
Yeah, cool. 12.2, that's what I got. Okay, and therefore, the variance of the coded data is going to be the same, so we can pop that in. So we're going to go this, which is the one we want to find, over 18 again, minus our new mean. So what did we say our new mean was? Let me just go 58 over 9 minus 5, square that, and that should equal 12.2. Rearrange and solve. Cool, so we're getting 257 as our final answer for this. So, there we go. That's it. Okay, how are we feeling? Are we making progress? Okay, let's try another one. So the next one is Amy measuring her pulse rate while resting, x beats per minute, at the same time each day on 30 days. And these are the results summary. So what's n in this case? N equals 30. I actually did this one, I got it wrong the first time, but I got it wrong, but I realised I'd got it wrong because I got a ridiculous pulse rate. So sometimes you can kind of go, that doesn't sound right. Like, I got something like 25, and I was like, I don't think that's right. So redid it, and then got it right. 80. Okay. So find the mean and standard deviation. So, what do you think? What can we do? We could find, what would our first step be? If we want to find the mean of her actual pulse rate, what could we find with this that we've got here?
Do we do 1 minus 147?
Divide by 30, which is the mean of the coded data, right? So, mean of coded data. Yeah, good thought. So, well done. Divide that by 30. What does this give us? Negative 4.9? Yeah. Now, what do we know about coded data? The mean has just been shifted. To get here, we've shifted it minus 80. So to get back to the original mean, we just need to add 80. Therefore, mean equals, maybe we'll say of uncoded data, is equal to minus 4.9 plus 80, which gives us 75.1. That makes sense for a pulse rate. It sounds okay, doesn't it? It's logical, possible. Okay, so the next thing we have to do is find the standard deviation of your pulse rate. We can just use the uncoded, the coded data, can't we? Because standard deviation is the same either way. So standard deviation equals square root. Okay, not variance. We're being asked for standard deviation. So square root of What am I going to put in here, Rebecca?
Do you want the formula or the values?
Yeah, let's. Are you feeling comfortable with the formula now? Yeah, just chuck in the values.
952 over 30.
Yep.
Minus, could you use minus 4.9 squared?
Because that's our mean. You're on it. Equals 2.78 to 3 significant figures. Let's do October 6.1. 6.2, sorry. In values, we've got this, sum of x minus 100 is equal to 216. And we've got sum of x equals 2416, and we've got to find out what n is. Okay, this is a bit different, this one. So we have, this is, we've added up all of the items of n items of data to get this. This one, we've got that, but then we've subtracted 100 n times. So in other words, 2416 minus 100 n equals this. Now let's just refresh and just make sure we understand why that is. This we've added every single x value together. This one we've added every single x value together, but for each x value, and there are n x values, we've taken 100 off. So that we've taken 100 off n times. Thus, if we subtract 100n from this, we get to that. And then we just rearrange. What are you getting for that, Hassel?
22.
22, that's the correct answer. Okay, last one. Well, we've done pretty well. Done a lot. The time taken in T hours to deliver letters on a particular route each day is measured on 250 working days. So N equals 250. We know that the mean time taken is 2.8 hours. We also know that sum of t minus 2.5 with 90 is 96.1, and we've got to find the standard deviation of the times taken. Okay. Okay. Well, if we know this, there's only one other thing we need to find to get the standard deviation. This over n minus the coded mean squared. So can we work out a coded mean from the uncoded mean? Yes? How do we do it? To get from normal mean to the coded mean, we're going to go 2.8 subtract 2.5. Does that make sense, Hasuk? You happy with that? So therefore the coded mean is 0.3.
What's subtract?
Because we're taking, this is uncoded, and for each uncoded item, which is t, we've taken off 2.5.
Okay.
Yep. Okay, so therefore we can say standard deviation is equal to the square root of, now we're using coded data for this, and that doesn't matter because it's going to be the same as the uncoded. So we're going to have 96.1 divided by 250, subtract 0.3 squared. What are you getting, Hassel?
0.5.
Yep, and three significant figures, 5 and 3. that is that.